All right, here we go. Here's the fundamental theorem of calculus. They're telling us that we have this integral expression, and this integral expression, they want to give it a name, they give it a capital F. And then they're telling us that they're taking the derivative of capital F, and they're just getting the inside expression. All they do is replace that t with an x. And then this is the proof of that, all that. Apply the difference directly to the function, blah, blah, blah. And you're supposed to look at that and be like, oh, okay, I get it. And then you look at that, and then it continues to the next page. And then they're like, oh, okay, that's the moment of genius. Yes, I can see. And then there's the proof. And then that's it. It concludes the proof. Do you guys get that proof? Okay. I know I've learned a long time ago that most, I would say a very high percentage of individuals that are learning math are visual learners. So I do not know why they think that you guys can just look at that and be like, oh, I got it. So I'm going to draw a picture of everything they're trying to do there. Okay? So let's start. So go to the next page, and it says, it starts with this. That's what they name it. And all we know right now from yesterday is that this means area from x equals a to x equals x of some graph. That's all we know. Okay, so that's what I'm going to do. I'm going to draw a line, and I'm going to draw some random curve. And we can call it, since they're in the t domain, we can call it f of t. And I'm going to say this is a, and I'm going to say this is x. And I'm going to put the y-axis right here. Maybe I don't have to go that deep, but just... And this is f of t, I guess. Or that's fine. That's a y-axis. All right. So all I know right now, so I'm going to start with this. F capital of x is equal to integral a to x of f of t dt. And they're calling that f, capital F. So all I know is that whatever this area is, remember that's all we know, that we're calling that capital F of x. That's what we know, right? Area under the curve from x. They're telling us area under the curve from a to x is f.
So capital F.
Yeah. Lowercase f is just this curve at the moment. Okay. Are we still okay? All right. So now, what about this one? If I were to write, if this is f of x, capital F of x, then capital F of x plus h, do you guys agree, is the same thing as integral from a to x plus h? Is that a true statement? Okay. Now, from what you learned yesterday or 2 days ago, I know that this one means, I'm going to say that h is, let me see. I'm going to say that I'm trying to make h as small as possible. So I'm going to say that's h, which is just a change in x. So then that means this point right here, that point has to be x plus h. And I guess to color code it, so we can have a good understanding. So I'm color coding it, guys. You don't have to outline it. You can just do the outline just for the F capital. That means this area, right? So, and that means all this. I'm going to do it the other way. And that's included that little piece. That means that, right? Okay. All right. No one's confused, right? Everyone's good? All right. Remember that yesterday we said that we could have done this. So I'm going to put that equal sign. I'm still doing the f of x plus h. So I could do this. I could go integral from a to x of f of t dt plus, where this one ends, the other one begins, integral from x to x plus h of f of t dt. That's the same thing, right? That will give me that f of x plus h. Okay. Where this that I just circled, that is capital F of x. Are we still okay? Okay. I'm going to move, and I guess I want everyone to see it, so I'm just going to write it. F of x plus h. I'm going to move this guy to the left, but I'm going to write this one first. So I'm going to write it like this. Integral x to x plus h of f of t dt is equal to, and I'm going to write f of x plus h, the capital F, minus, and then I move that guy to the left. I'm not going to write the integral symbol. I'm going to write capital F of x. Are we still okay? Do we understand what we just did? What's up, Gonzalez? Tell me. Dime. This integral from a to x of f of t dt is the same thing as f of x. So I could have just replaced that with f of x, and all I did was move it to the left. So f of x plus h minus f of x, but I wrote it on the right. Cool? All right. Now here's your A game part. Okay. Okay. Yeah. We still understand everything right now, though, right? Okay. Do you guys agree that this that I'm underlining in green just means this little rectangle here in green? Yeah, that's what it means. F of x plus h minus f of x. Okay, that just means that in green. And if I assume that that's a rectangle, I can approximate the area of that rectangle by saying that is nothing more than, let's see, the distance between x plus h and x is just h. Does everyone know where that h came from? Yeah, just in case, I'll write it here. X plus h minus x, the base of that rectangle, times, and we're going to use an LRAM. So this point right here, if I were to go all the way to this y-axis, that is f of x, because I'm using an LRAM, the L coordinate for that rectangle. Do you see it? Because we could also say h approaches 0, and it would still be f of x, because if h approaches 0, you're right on x. Okay, so I'm going to say, because there is no f of h. That would have been f of x plus h if you wanted to use an RRAM. But then I'm going to make h approach 0, so it's going to be going to the left anyways. Yeah, you said, like, why can't that? You're trying to use this one. It wouldn't have been f of h. It would have been f of x plus h. But then if I say h approaches 0, then you're going to be back at f of x anyways.
Oh, so it's kind of like the whole, like,
yeah, it's a matter of fact, that is good thing you brought that up. All right, are we okay right now? This right now, guys, is where, okay, so check it out. I'm going to see if I can go real slow now. So this is just that area of that rectangle, right? I want you guys to realize, look what happens. Divide by h, divide by h, divide by h. I'm going to put it at like 1 over h. So right now, we are in this, you see that little 1 over h, x plus h, f of t dt? If you were to look at your proof, we are right here. Look at that. And, oh, man, they're messing it up for me because I wanted we to come out. We're right here. Oh, man, they're messing it up for me, too. We're right here, look. But they're all messing it up for me because you're getting to see the proof. I want you to realize something. So I'm not going to write the left side. I'm just going to write the right side. So, look, I want you to realize something. So, and I'll explain it in plain English what I want you to accomplish. I don't want this to be an approximate f of x like this. We already know this would have been the area there. If I want this to be exact, I need to write limit. Do you know what I mean? Because I don't want approximate, I want exact. So if I write the word limit in the front, it now becomes exact. So look at this. Limit as h approaches 0 of f of x plus h minus f of x all over h. Now that's going to be exactly f of x. Are we okay? Okay, here's the big deal. Big one. And don't worry, I'm slowing down. Do we understand everything we've done so far? More or less. This that I'm circling, yeah, ask. It just came from area of this rectangle, and I said use LRAM, and I used the leftmost point. So the area of that rectangle is h, which is x plus h minus x, times the height, which was just f of x. Okay. That's why it's an approximation. The further away you are from the x, the worse the approximation is. But yeah, but then as soon as we put the word limit, because h is approaching 0, now we're right on it. Okay, so now here we go. This right here that I'm circling in black, looks like what from the first semester? The definition of a derivative. Now, it's a specific derivative. You see how that says capital F? So this is the definition of derivative, but for F. This is the definition of capital F prime. Because well, if I would have had the letter G, I would have said definition of G prime. If I had a little f, definition of F prime. Right? Definition of derivative. So because this is derivative, look what this means. F prime of x is equal to f of x. And I know at first glance you're like, Chav, I do not understand anything that you're just saying. Let's look at what the big picture means. What was big F to begin with? Big F to begin with was this integral right here. Integral a to x of f of t dt. That was my big F, right? So if I take the derivative of this, look how powerful this is. F prime of x. They're telling the derivative of this is itself, the expression on the inside, f of x. It doesn't matter what the lower limit is, as long as it's a constant. The upper limit must be x for this to be true. Because as soon as I put a number up there and I take a derivative, now you're taking the derivative of a constant and it's 0. So now look what this is saying. Capital F prime is equal to f. So what does that mean? And I'll write it up here. This means, unless I write it right here. Okay, no, I'll write it right here. This means that d dx of this integral from a to x of f of t dt is just f of x. So the antiderivative. So that's the definition. So now we know that if you see the integral symbol without a derivative, it just means to do the antiderivative. Because look, if the derivative of this integral symbol of f of t dt is f of x, then that means if we just see this, then you should be like, oh, that just means f of x then. F of x plus c, of course. But that's part 2. We'll get to part 2 in a little bit. Don't worry. We'll get there. No. We'll get there in a little bit. All this, okay. This is just telling me the derivative of this that I'm putting in brackets is just f of x. Notice that I have f of t right here. So all that's happening is as long as that x and that x match, the derivative of this integral cancels each other out. And whatever expression you have, you just type in that letter. And now we're just going to do a whole bunch of practice. A whole bunch. Cool? Yeah. Write it down, guys. Write it down. Did all that make sense? Okay. Yes, ask. It cancels each other out. But remember that you weren't supposed to know that the integral means antiderivative. This is where you realize that the integral means antiderivative, because you're looking at it and you're like, derivative of this integrand symbol just gives me the inside. Wait a minute. If I'm taking derivative of that integrand symbol and I just get the inside, that means if I do not take the derivative, it should be the antiderivative. Like, do you see where we're going to? Like right now, you know it's antiderivative because we cheated. I told you. But look, here's the logic. I ruined the magic for you guys, and I'm so sorry that I ruined it for you guys. Here's the logic. When you take this derivative of this symbol you never seen, the derivative of this integral of f of t dt, you're telling me that it's just the inside? It's just whatever this was on the inside? So if I take the derivative of this integral, you just get the inside. So this is where the magic comes when we do the next one. So if I don't take the derivative of this integral, that must mean it must be a antiderivative. Yes, I'm taking the derivative of this symbol that supposedly we've never seen. We've seen it many times. We cheated because we already told you what it means. But the derivative of this integral means I just keep the inside, put the x in it. That's taking a derivative, right? So yeah, because it's like canceling out. So if I do not take a derivative, it must mean that I have to take a anti. That's for part 2, but we're already getting ahead of ourselves. Cool or not cool? All right, look how easy it is. Relax. Let's say you understood nothing. Chavez, I understood nothing. Okay, all you got to be able to do is just apply it. Can you apply it? Here's how we do it. It says d dx, so you're taking a derivative. Do I have a constant in the lower limit? Do I have an x at the upper limit? Okay, this is your f of t, the cosine t. So the derivative of this is just cosine x. Done. That's it. That's it. So if you did not understand the proof, that's all you got to be able to do. Apply it. That's it. The derivative of the integral is just whatever I have on the inside. All right, letter B. Do I have a constant in the bottom? Do I have an x at the top? So the derivative of this expression is just 1 over 1 plus x squared. Done. That's it. Yay or nay? All right, now let's see if we can do it with chain rule. See if you guys get it. Don't worry, it's very basic. I'm telling you that y equals this expression. Ready? Yeah, y prime. No. You'll see right now. So, do I have a constant in the bottom? Do I have an x squared? Do I have a variable on the top? But it's not x, it's x squared. So here's what you do. You're going to replace a t with a x squared. So you're going to write cosine. Notice it says y prime. Cosine of x squared, and you're not done. It was not an x. It was an x squared. So what's the derivative of x squared? 2x. Now you're done. Make it pretty if you want. Y prime equals 2x cosine of x squared. See, you guys are already pros. Let's do another one. Ask.
Didn't you say there has to be like the same variable like on the outside and on the inside?
No. It could be any variable on the inside. I just have to have an x.
No, I meant like don't there have to be like on the other side of the equal sign on the like isn't that y supposed to be?
No. That's an equation. Y equals something. G equals something. I can call it whatever. I mean, this, it says dy dx. If I were to call this z, then I have to be dz dx, you know? But, okay. All right, here we go. Next one. Look at this. It wants a derivative, but notice, do I have a constant on the lower limit? Do I have a variable on the upper limit? So all I have to do is what? Perfect. Y equals, I haven't taken the derivative. Negative, there's just the properties. Integrand 5 to x 3t sine t dt. Okay, now I take a derivative. Y prime equals. Now I can take a derivative. That negative is this negative. I'll open up a parenthesis. You don't have to because it's all a product, so you don't really have to. And then 3x, 3, that's a t, right? So wherever there's a t, you put a x sine x. Done. Since it's all a product, you can just drop the parenthesis. You can just say negative 3x sine x. Are we okay? Okay, nothing crazy. All right, here we go. OMG, Chav, I don't know what to do to this one. Relax. No. Don't. So. All right, your properties, guys. Here we go. I have a variable on the bottom. I have a variable on the top. I cannot take a derivative right now. You have to have a constant on the bottom. So we're going to do two properties. First, separate the integral like this. Y equals integral from 2x and pick any number. I usually like to put the number 1. Or you can make it a letter. No, don't make it a letter. Put a number. Make it to 1. Go to way to 1. Any number you want, as long as it's a number that is not a vertical asymptote. And this one doesn't have a vertical asymptote. 1 over 2 plus e to the t dt. And then plus, where this one stops, the other one better start. 1 to x squared of 1 over 2 plus e to the t dt.
Does it matter at all like what number?
No, you can put a letter A if you want and say A is a constant. But right now we're rookies, so I just choose like 1 or 0 or something. Are we okay right now, guys? All right. I can't take the derivative of this one yet. Once you get super advanced, you can, because I know some of you will be able to just skip a step and just put a negative. But before I take the derivative of this, I need what to be in the bottom? A constant. So y equals, flip it, 1 and then 2x, and then 1 over 2 plus e to the t dt plus integral 1 to x squared, 1 over 2 plus e to the t dt. Are we okay so far? All right, now we're ready. Oh, I didn't put a negative. There it is. Negative. Now we're ready. Y prime equals negative in the front. You can put all this in parentheses if you want, or just put the negative in the center there. E to the t like that. Oh, e to the 2x. We're not done yet. E to the 2x times 2. So I'll fix it in a little bit. Plus 1 over 2 plus e to the x squared times 2x. So here, let me fix it. So it's going to look like, I'm just going to fill it in right here. Negative 2 over 1 plus e to the 2x plus 2x over 2 plus e to the x squared. What are the what? Oh, it's a 2. Sorry. It's because we were doing composite argument properties a little while ago in pre-calc. Do you guys remember? And tan a minus b has a 1 in the lower left-hand corner. So it's still fresh in my brain. That's what happens when you do pre-calc and calc, when you mix them. Okay. Are we okay so far? I don't see any other errors. Thank you for fixing my mistakes. I make mistakes all the time. Are we cool, guys? Okay. Now here we go, Parachello. Ready for this? This is where you should be for the first time seeing that this means antiderivative. But we cheated you guys, so I'm sorry. It says if f is continuous at every point a, b, and f, capital F, is an antiderivative of f on a to b, then blah, blah, blah. Okay, I know. You're like, we're not mathematicians. What the heck is this? Here's what they were trying to say. If you have a to b of f prime of x dx, it's nothing more than f of b minus f of a, which is what we have right here. That's what they try to tell you. And it's supposed to be obvious because of the first one of this, because of the first one when we were like, I'm trying to get to here, because of this. See how this one, the derivative of this integrand just gave you f of x? So if you erase the derivative, it must be a antiderivative. Does that make sense? So that's what they're trying to say. Notice that there is no derivative. Notice that there is no derivative symbol. Oh, man, why can't? There we go. Notice that there is no derivative symbol there in the front. Do you guys see that? Yeah. So all it is just antiderivative, top minus bottom. When I say top, limit of the top. And we're going to do a whole bunch of this. This is what, and you pretty much already know 90% of the exam. All you need now is slope fields and differential equations. So now you know 90%, you can get a 5 already. Now it's just applying it. Now it's just applying the math, you know?
So if there's no derivative, you're going to basically subtract the
antiderivative of the top minus antiderivative of the bottom. We're going to do a whole bunch. We're going to do a whole bunch right now. We're going to start right now. Okay. So here's a common mistake, guys, that some of you get real confused. Delta Math does it. So do the textbooks. Sometimes, this is just for the record, just take this in. It's understood that when you see this, not everyone is going to be putting parentheses on the x cubed plus 1. Don't take this as, oh, it's dx times 1. No, you need this differential. You need that dx. That's your, remember, that's like your area under the curve. Height times width. It's actually, this is your height. It is in parentheses. But that dx indicates the end. Sometimes there's parentheses. Sometimes there's not. It just indicates the end. Are we okay? All right. Here we go. You guys ready? Integral of this. So here we go. Negative 1. Let's practice just writing the antiderivative like this. And I'll put the equal sign. And here's the correct way. Put a bracket because you have more than one term. What is the antiderivative of x cubed? Antiderivative. Add 1, divide by. Yeah. I'm going to write x 4 over 4. Plus, what's the antiderivative of 1? X. Do not put plus c. If you have limits, you don't need plus c. Close it with your bracket. And in the bottom bracket, put negative 1. And in the top bracket, put a 3. Are we still okay? Now, you can put an equal sign here, or you can just continue it now, however you want. You can put an equal sign here, or you can put, I'm just going to continue here because I have more space. So now I'm going to do upper minus lower. Cool? So here we go. When I say upper, I'm going to plug in a 3 wherever there's an x. So giant parenthesis, 3 to the 4th over 4 plus 3, close giant parenthesis. You're not done yet. You've got to do the minus lower, right? Minus, open another giant parenthesis, negative 1 to the 4th over 4 plus negative 1. Close giant parenthesis. Everyone see what we did? Okay. Cool or not cool? Okay. Right now, we are just beginning, so let's go ahead and see if we can do this. All right. 3 to the 4th. 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. 81 over 4, I don't know what that is. 20.25, I'm going to leave it like that. Plus 3, in a little bit, I'll change that. Negative 1 to the 4th is 1, so 1/4 minus 1. Okay, I think I can do this. Ready? 3 times 4 is 12. So I'm going to change that 3 to a 12 over 4. And so here's what I see now. And I'm going to turn that 1 into 4 over 4. Equals 81 plus 12, 81, 91, 92, 93. 93 over 4 minus, let's see, 1 minus 4 is negative 3. So plus 3/4, 93, 94, 96. 96 over 4, which reduces to 24? Yeah, 24. Perfect. Yeah. I think that's correct. How do you feel? Okay, I'm going to show you how to use, do you guys already know how to use the integral symbol for calculators? Okay, I'm going to show you how to use it. I just do not use it to put the answers on delta, just use it to verify, guys. So here we go. I'm going to show you how to use the calculator. So I'm going to do the same one in the calculator. Negative 1 to 3 of x cubed plus 1 dx. Take your calculator out. X cubed plus 1. I actually prefer to use a y equal sign a lot, but that's fine. Look, there's that one in that corner that I was telling you about. Push math, and it's number 9. Do you see that integral? Lower limit, negative 1. What was the upper limit? 3, right? Or 3? And then what was the expression? X cubed plus 1? X cubed, x caret 3, move plus 1. Plus 1. And then I put an x over here, and we should get that 24 answer. And there it is. Now, there's limitations. Calculators have limits, but this is a simple enough polynomial that it can do it relatively simple. Cool or not cool? Yeah. All right. There it is. We did it with the calculator, guys. All right. Don't worry, we're almost done. This is how it's going to look. All right, hopefully your heads don't hurt. This, I'm super excited because now we can actually do like 70% of the free response questions after today. So now we're going to start really doing a whole bunch. So look what it says. Using the graph of f to analyze h of x. The graph of the continuous function f with domain 0 to 8 is shown to the right. So what graph do I have in the right here? F. Just put f. Let h be the function defined. Notice that h is defined by an integral symbol. Are we okay? All right. Find h of 1. All right. Hopefully we have some experience from yesterday. H of 1 equals the integral from 1 to 1 of f of t dt, which is 0, because have you moved? No. So you're done. That's it. All right. Next one, letter B. Is h of 0 positive or negative? Well, I don't know. Let's see. H of 0 equals integral from 1 to 0 of f of t dt. It's negative. Why is it negative? You're counting backwards. You're going to say, since area is above x-axis and we are starting at x equals 1 and ending at x equals 0, comma, h of 0 is negative. I think that's enough justification. Yes, because you're going backwards. You can actually say going backwards, and that should count it, but you might have a professor that might say, well, what's backwards? So, we start at x equals 1 and you end at x equals 0 for your integrand. So you're counting backwards, hence hence h of 0 is negative. Letter C is the one that I'm most excited about. All right. I can't wait. I'm actually a little nervous now. Letter C. Find the value of x for which h of x is a maximum on the open interval. So I don't have the graph of h, but I do have the graph I know this is graph of f, but what is it in terms of h? You got it almost correct. What did we just learn a little while ago? The fundamental theorem of calculus. Do I have a constant on the bottom? Do I have a variable on the top? So I can say that h prime of x is equal to f of x. Perfect. H prime of x equals f of x. That's FTOC. So that means this graph, I'm going to all of a sudden, instead of f, I'm going to put equals h prime. So I have a maximum whenever the derivative goes from what to what? Positive to negative. So look at you don't even look at the endpoints, just look at the interval. Where do I go from positive to negative on that graph? At 4. Do you guys see that? At 4 right here, look. Positive, negative. So here's how you're going to write it for full credit, guys. You're going to write h of x. You gotta don't say the word it, because it is like, what are you talking about? What graph? The graph or it. Okay. H of x has a maximum at x equals 4, since h prime of x, which equals f of x, is changing from positive to negative. And I know it sounds silly to re-say it, but re-say it. At x equals 4. H of x has a maximum at x equals 4, since h prime equals f of x is changing from positive to negative at x equals 4.
Why do we change variables? Like, why does it go from f of t to f of x?
Oh, you took the derivative with respect to x, so the f of t turns to f of x.
Okay.
But if you squint your eyes a little bit, that x kind of looks like a t, and you know, like. Okay. How are we feeling? How are we feeling, guys? Todas, we got it so far? Okay. Find the x-coordinate of all points of inflection on the graph of y equals h of x. Okay, here we go. And I should have put justify. Justify. So I know, what do I know? I know that h prime of x equals f of x, right? I know that I am concave up when what? H prime prime is positive. Okay, so you can, if you want, write h prime prime of x equals f prime of x. I think the best graph to reference is the one you are given. So this is the one I'm given, right? So I'm gonna state my inflection points based off of h prime.
Isn't it where f prime has a maximum?
Increasing and decreasing, yeah.
Where that graph is
So increasing and decreasing, because it wants points of inflection.
oh,
Since it wants points of inflection, I want to know where I change concavity. So where I go from concave up to concave down, and from concave down to concave up. So let's look at this graph. Wherever there's a max and a min. But I would state wherever there's a max and a min on h prime. But the better answer is wherever h prime changes from increasing to decreasing, or vice versa. Both will be correct, but okay. The one. All right, here we go. Where's the first one happen at? 1, because h prime changes from decreasing to increasing. Where's the next one happen at? 3, and there's another one more. Where does the next one? 6. So I'm going to write, here's how I'm going to write for full credit. Points of inflection on h of x occur at x equals, what was it, 1? So 1, 3, and 6. And always state the first one first, because h prime, which equals f, you can say h prime equals f instead of h prime of x, which equals f of x. Or it doesn't matter. I'm just trying to write fast, because h prime, I'll write it the proper way, because the professors will probably hate it. H prime of x, which equals f of x, changes from decreasing to increasing, and vice versa, at those specific x values. Period. Full credit. How do we feel? Okay. I'm just gonna put some simple one, guys. I just want you guys to test it out during class. Some FTOC problems, just to knock out any hiccups when we have. As you saw, it was pretty simple, right? So I'm just gonna create some simple delta math. It's not gonna be a lot. 10 questions. You'll probably be done probably in the next 20 minutes, and then the rest of the time will be for yourself. Cool. All right, that's it, guys. Good job.